We're going to do some more with simplifying radicals. This is video number 2 of 3 that I am doing. All of these examples are going to be dealing with multiplication. So you're going to see problems that have some multiplication with the radicals, and it'll probably just say simplify. All right, here again, before I have started this, I do have my list of perfect square roots, which is going to come in handy once I start to break it up into a low factor tree to simplify my radical, and then just reviewing that even exponents, the square root of like x to the fourth is going to be an x to the second. Just reviewing that from the first video, part 1 that I did. All right, so let's say start out here. First thing you're going to want to do, you can multiply what's underneath radicals. All right, so that's what I'm going to do. This says square root of 8 times the square root of 12. So I'm actually going to go 12 times that 8 right there, and I'm going to get 96. So then I've got the square root of 96. Once I get to that part, I'm going to simplify it just like I did in part 1. I'm going to come over here. I'm going to try to find the biggest perfect square root that goes into 96. All right, turns out that 16 goes into 96 6 times. So then I'm going to break this up into the square root of 16 times the square root of 6. Okay, by choosing this being the biggest perfect square, then I'm only going to have 2 rows here. Square root of 16 gives me a 4. Radical 6 is as simplified as it can go. So then I've got 4 square root of 6. All right, so simplified answer there, 4 square root of 6. Okay, now I've got another example here showing some multiplication. This time there's some coefficients out here outside that radical, and then you've got stuff underneath radical. When you multiply, you may multiply the coefficients together. You may also multiply what's underneath the radicals. So that 3 times 4 is going to give me a 12. And then 2x times 10x is going to give me a 20x squared underneath my radical. Okay, so now I'm going to simplify this. That 12 has already been simplified. I mean, it's the coefficient out in front of the radical, so I don't need to worry about it. That 12 is basically just going to come down in every line that I do. Okay, so we'll go ahead and put that 12 down there. Now, like I did in part 1 in the first video that I showed, I broke up the coefficient and the variables, so I'm going to do that here. I'm going to break this up into square root of 20 times square root of x squared. That way I can deal with them separately. The 12, like I said, is done. He's just going to come straight down. All right, now this radical 20, I want to come up with the biggest perfect square from this list that will go into 20. Turns out that it is the square root of 4 times the square root of 5. 4 times 5 is 20. Okay, and then let's go ahead and finish this before I start over there. The 12 is going to come straight down. The square root of 4 is 2, which is what I wanted. That square root of 5 there is as simplified as it can get. All right, now let's come over here and work with this square root of x squared. All right, well, it's an even exponent, and when it's an even exponent, I can just take half of the exponent. So square root of x squared is just going to give me a plain little x, and then he would just come all the way down. All right, so you go through, you find everything that you have taken out that is outside your square roots. 12 times 2 times x is going to give me a 24x. And square root of 5, then there's only one thing underneath the radical, so I can just set it up there against that. So final answer, 24x, square root of 5. All right, so just 2 quick little examples showing how you can multiply radicals and then go into the simplifying of them. If you like the video, that'd be great. Give me a like, and you can also share with your friends. Thanks.